Hi, physicists. We're going to talk about velocity. We already know about change in position. Here's Martha. She started at position xi is 4. She ended at position xf, or final position 9. That is the displacement, delta x. But what if, while you're displacing, you time the whole thing? Then you've got how far you displaced and how long it took you to do that. Those can be combined into one thing we call velocity, the rate of change of position per time, or delta x over delta t. Velocity v is the change in position divided by the change in time. It gives you a sense of how quickly a object is being displaced. Remember, delta x is xf minus xi, so you can expand this formula to write it as v equals xf minus xi over delta t. Which one of these forms you use is just depending on the situation. Which variables do you know? Do you know delta x, or do you have the components xf and xi? Here's an example. Karam runs 50 meters in 12 seconds. He then turns around and runs backwards 25 meters in 8 seconds. What was Karam's velocity over the entire trip? So we've got to piece a couple things together. The first thing is to realize that if Karam ran forward 50 meters, then backwards 25, his displacement is going to be 25 meters, starting at position 0, ending at position 25. So we can calculate delta x, and we know that the total time is the 12 seconds plus the 8 seconds, so 20 seconds. Now that we have delta x and delta t, we can calculate velocity, delta x divided by delta t, or 25 divided by 20, and that gives us 1.25. Notice the units here. We divided meters by seconds to get meters per second. Quick summary. We know displacement is change in position xf minus xi. Velocity is that change in position divided by the amount of time it took to change that position.